The spring of 1943 presented an unrelenting series of challenges for the High Command of the 8th Air Force, whose English headquarters were inundated with grim loss reports. The arrival of the P-47 Thunderbolt in the European theater had been heralded with grand pronouncements of its invincibility, a formidable machine comprising 7 tons of American engineering prowess, all built around the most potent radial engine ever integrated into a single-seat fighter aircraft. However, the harsh realities encountered over the skies of occupied Europe painted a starkly different picture, a narrative eloquently told in the lingering smoke trails of downed aircraft and the distressing number of empty seats at post-mission debriefing sessions. The 56th Fighter Group initiated their combat operations with the Thunderbolts on April 8, 1943, undertaking critical escort duties for B-17 bombers engaged in devastating strikes against German industrial complexes. Within a mere fortnight, the reports submitted by the pilots began to generate considerable apprehension among procurement officials situated in Washington. The P-47 exhibited a distinct sluggishness when operating below 15,000 feet, an altitude where the agile Focke-Wulf 190s effortlessly outmaneuvered the heavier American fighters. Its rate of climb proved disappointing, and its turning radius was, frankly, a source of embarrassment. Moreover, the Luftwaffe had swiftly identified a critical vulnerability. A head-on attack followed by a rapid split-S maneuver allowed German pilots to vanish from sight before the Thunderbolt pilots could effectively bring their weaponry to bear. Colonel Hubert Zemke, the commanding officer of the 56th, spent those initial weeks absorbing the grievances of his pilots, who colloquially referred to their combat aircraft as the 7-ton milk jug. The Thunderbolt, as prodigious fuel consumption meant that any meaningful duration of escort time over German territory remained an elusive fantasy. Pilots would cross the English Channel, provide babysitting services for the bombers for perhaps 30 minutes, and then be compelled to return to base before their fuel reserves were completely depleted. In the interim, Messerschmitt 109s and FW-190s patiently awaited the departure of the Thunderbolts, subsequently launching unhindered and devastating assaults on the vulnerable bomber formations. The tactical situation was further exacerbated by critical deficiencies in the pilots' situational awareness, or more accurately, their lack thereof. The P-47's distinctive razorback canopy design created significant blind spots, transforming the vital act of checking one's 6 o'clock position into an arduous and often inadequate neck-straining exercise. Luftwaffe pilots exploited this design flaw with ruthless efficiency, expertly positioning themselves within these dead zones before initiating their attacks. After-action reports, compiled throughout April and early May, meticulously documented numerous instances of P-47s being ambushed from above and behind, with the initial indication of an assault often being the jarring impact of 20mm cannon shells tearing through the fuselage. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Please write a comment about where you are from and what you think about the video topic. By mid-May 1943, a subtle undercurrent of concern permeated among certain staff officers, with quiet suggestions emerging that the P-47 program might regrettably prove to be a billion-dollar misstep. The aircraft undeniably performed with exceptional grace and efficiency at altitudes of 25,000 feet and above, where its turbocharged engine delivered a performance envelope that could rival or even surpass any aircraft in the Luftwaffe's arsenal. However, actual fighter combat seldom remained confined to such lofty heights. Dogfights invariably spiraled downwards, and at lower altitudes, the Thunderbolt regrettably transitioned from a formidable predator into vulnerable prey. Compounding these issues, early combat losses hinted that the aircraft was not absorbing battle damage with the resilience its engineers had confidently promised. Within the first month, 3 P-47s had been lost to what appeared to be relatively minor damage, engine fires, structural integrity failures, and control system malfunctions that ultimately proved fatal. The 78th Fighter Group commenced operations alongside the 56th during April, and their experiences regrettably mirrored these mounting problems. Pilots consistently reported that German fighters appeared noticeably emboldened, pressing their attacks with greater audacity and for longer durations than they had against other American aircraft types. Intelligence officers posited that the Luftwaffe had meticulously conducted their research, thoroughly scrutinizing the P-47's performance envelope and adeptly identifying its exploitable vulnerabilities, initiating attacks from below and behind, forcing the Thunderbolt into disadvantageous turning engagements, and specifically targeting its large radial engine with incendiary rounds. It became evident that standard Luftwaffe doctrine was undergoing a specific evolution designed to effectively counter American tactical approaches. Robert S. Johnson had been actively flying P-47s with the 61st Fighter Squadron, part of the 56th Fighter Group, since March 1943. By late May, he had accumulated sufficient combat hours to intimately understand the Thunderbolt's inherent strengths, while simultaneously cursing its pronounced weaknesses. The aircraft conveyed a sense of robust solidity, almost a comforting mass, yet this very bulk rendered it ponderous and unwieldy in the intense close-quarters maneuvering of a knife fight. Johnson had observed numerous squadron mates making critical errors, attempting to engage FW-190s in turning contests, or trying to climb away from diving BF-109s. He had also attended the somber gatherings that inevitably followed when those pilots failed to return home. The ultimate unanswered question, however, the one that transcended considerations of mere speed, climb rate, or turn radius, remained untested. What truly transpired when a P-47 sustained severe damage? When German weaponry found its mark and savagely tore into that massive airframe? Could the Thunderbolt genuinely absorb such punishment and continue to operate, or would it simply disintegrate like any other fighter once battle damage surpassed its structural limits? The engineering reports provided one set of answers. Actual combat, however, was poised to deliver another. And on May 26, 1943, Johnson was about to unwillingly furnish the definitive answer that everyone had been desperately awaiting. The morning of May 26, 1943, commenced much like any other mission day at Horsham St. Faith Airfield. A persistent cold English drizzle, the familiar rituals of nervous pre-flight checks, and ground crews tirelessly swarming over P-47s that seemed to be in a perpetual state of needing repair. Johnson's aircraft for this particular mission bore the standard Republic Aviation serial number 42-8487, a Thunderbolt that had accrued approximately 40 combat hours without experiencing anything more dramatic than a few minor flak dings. The mission briefing outlined a seemingly straightforward bomber escort assignment to Saint-Omer in northern France, with the primary objective of protecting B-17s as they targeted German airfields and vital rail yards. The 56th Fighter Group launched a formidable contingent of 58 P-47s that morning, meticulously forming up over the English coast before setting a course southeastward across the Channel. Johnson was positioned as part of the 61st Fighter Squadron's second element, strategically tucked into the formation where he could maintain uninterrupted visual contact with his flight leader, while simultaneously scanning the vast expanse of the sky for those ominous dark specks that invariably signaled impending danger. For once, the weather proved cooperative, scattered clouds at 8,000 feet, with clear skies above, offering visibility that stretched for many miles. These were ideal conditions for spotting both the bomber formations below and any potential enemy fighters lurking above. They penetrated French airspace at an altitude of 26,000 feet, with throttles precisely set for maximum endurance. The bomber stream extended beneath them, comprising 17 distinct groups of B-17s, proceeding towards their targets in a seemingly orderly procession that, from their vantage point at altitude, belied the underlying controlled chaos of the actual operation. Johnson's role, in theory, was disarmingly simple: to diligently keep German fighters away from those vulnerable bombers until dwindling fuel levels compelled the P-47s to initiate their return journey home. In practice, this demanded an unyielding vigilance, a constant swiveling of the neck, and eyes burning from the intense strain of ceaselessly staring into the bright sky, searching for enemy aircraft that possessed the unnerving ability to materialize from any direction. The initial indication that something had gone awry occurred at precisely 13:15 hours, when Johnson's wingman urgently called out, "Bandits at 4 o'clock high." Johnson quickly craned his head around, squinting intently through the P-47's canopy framework, and immediately caught the glint of sunlight reflecting off enemy canopies. They were Focke-Wulf 190s, perhaps 8 or 10 of them, diving aggressively from 28,000 feet, capitalizing on both their significant altitude advantage and the formidable speed derived from a perfectly executed bounce. The German formation meticulously split as it descended. Some fighters veered towards the bomber stream, while others specifically targeted the P-47 escorts. Johnson's flight leader promptly called for a decisive hard right turn to directly confront the incoming threat, and the Thunderbolts responded with the characteristic sluggishness that so often prompted P-47 pilots to curse their aircraft's considerable weight. The FW-190s continued their relentless approach, and Johnson, with the piercing clarity that only true combat can impart, realized that the geometric alignment was decidedly not in the Americans' favor. The Germans had timed their bounce flawlessly, catching the P-47s precisely in the midst of a formation turn, a moment when individual aircraft were at their most vulnerable. What transpired next unfolded within the compressed, distorted perception of time that combat pilots frequently describe, where every event seemed to occur simultaneously, while paradoxically feeling as though it were happening in agonizing slow motion. Johnson witnessed tracers arcing ominously past his canopy, heard the jarring metallic hammering of rounds impacting his aircraft, and felt the P-47 shudder violently under the force of the impacts. His initial instinct proved correct: brake hard left, thereby disrupting the attacker's firing solution, and extricate himself from the direct line of fire. He hauled the control stick sharply over, and the Thunderbolt, though ponderous, did respond, but not with sufficient alacrity. The FW-190 that had singled out Johnson was piloted by a Luftwaffe ace who knew precisely how to destroy P-47s, or at least believed he did. The German fighter closed the distance to less than 200 yards, essentially point-blank range where even mediocre gunnery could yield devastating results, and unleashed everything mounted in those formidable wings. 4 20mm MG-151 cannons, and 2 7.92mm machine guns, delivering an approximate combined fire rate of 1,600 rounds per minute, all concentrated with deadly precision on Johnson's Thunderbolt as the two aircraft merged in a crossing shot that, by all accounts, should have been immediately fatal. Johnson felt his P-47 visibly stagger as cannon shells savagely tore into the engine cowling, the fuselage directly behind the cockpit, and the right wing. The canopy panel situated immediately beside his head starred from a direct bullet impact that, by all logic, should have penetrated but somehow miraculously did not. A cascade of warning lights illuminated on his instrument panel, oil pressure plummeting, hydraulic pressure completely lost, and engine temperature rapidly climbing into the critical red zone. The control stick felt disturbingly wrong in his hand, mushy and unresponsive, as if the vital control cables had been partially severed. The FW-190 flashed past, and Johnson instinctively sought it out, knowing with absolute certainty that the German pilot would either break away or swiftly maneuver for a finishing pass. What he observed instead, however, caused his very blood temperature to plummet. The initial assault had left him in a perilous state, his vital signs plummeting as the cold reality of his predicament settled in. The menacing Focke-Wulf, having executed its first devastating pass, was now arcing gracefully, repositioning itself for a subsequent, likely fatal assault. Johnson's Thunderbolt, severely damaged and struggling, was rendered virtually incapable of any defensive action. The accompanying aircraft of his squadron had dispersed during the initial surprise attack, either pursuing other Luftwaffe adversaries or hastily evading the sudden, brutal ambush. Consequently, Johnson found himself isolated, already injured, and facing the grim prospect of enduring a second volley of enemy fire from a skilled pilot, intent on confirming his impending demise. This follow-up attack materialized from Johnson's 7 o'clock, the FW-190 seamlessly gliding into an optimal firing posture, with an almost instructional level of exactitude, while Johnson desperately wrestled with the unresponsive controls, attempting to elicit even the slightest evasive movement from his battered fighter. He succeeded in achieving perhaps a mere 15 degrees of banking before the aircraft's control surfaces seized entirely, an ominous sign that crucial control cables had either been severed by ordnance or hopelessly obstructed by contorted metallic debris. The German aviator, recognizing the absolute vulnerability of his quarry, proceeded with deliberate patience, reducing the distance to an estimated 150 yards, a proximity so close that Johnson could discern intricate features of the enemy aircraft, including the distinct contours of the cowling, the spinning propeller hub, and even what appeared to be celebratory victory tallies emblazoned on the fuselage. The subsequent barrage, a brief yet utterly devastating onslaught spanning approximately 3 seconds, inflicted truly catastrophic harm upon the already battered aircraft. High explosive cannon shells tore through the Thunderbolt's posterior fuselage, violently ripping away substantial portions of both the rudder and elevator control surfaces. Additional rounds ascended the aircraft's central dorsal structure, each violent impact resonating through the airframe as a sharp, metallic clang that Johnson experienced viscerally as much as auditorily. His starboard wing sustained numerous direct strikes, One particularly destructive shell detonated within the primary structural spar, causing the entire wing to contort and buckle in a manner alarmingly alien to its design parameters. The instrument panel directly before him violently disintegrated. Shards of glass exploded outwards. Indicator needles spun erratically into oblivion, and electrical conduits shorted out in chaotic bursts of brilliant sparks. Then a formidable 20mm shell slammed into the canopy rail, a mere 18 inches from Johnson's head. Although the projectile itself failed to penetrate the protective barrier, the sheer force of the impact fractured the plexiglass in a bewildering spiderweb pattern, rendering his forward vision a dizzying, distorted blur. Minuscule fragments peppered the right side of his flight suit, and he perceived the unsettling sensation of warm blood trickling down his neck, though he would only later ascertain that he had sustained shrapnel wounds to his shoulder and ear. The confined space of the cockpit rapidly became inundated with thick, acrid smoke. Its origin, whether from raging electrical fires or the direct consequences of battle damage, remained indiscernible, and the pungent, chemical odor of hydraulic fluid mingled sickeningly with the sharp metallic scent of cordite from exploding ammunition. Under such dire circumstances, Johnson's primal instinct should have been to abandon the stricken aircraft. The P-47 was unequivocally succumbing to its wounds. Vital systems were failing comprehensively, and its structural integrity was, at best, profoundly compromised. Yet an inexplicable force prevented him from reaching for the emergency canopy jettison handle. Perhaps several compelling factors coalesced to override this fundamental survival impulse. It might have been the considerable altitude, still hovering around 24,000 feet, a height that guaranteed an extended and exposed parachute descent, leaving him vulnerable to relentless targeting by German ground forces or patrolling aircraft. Alternatively, the daunting geographical distance could have been the deterrent. He was situated somewhere deep over northern France, with a perilous expanse of approximately 50 miles of enemy-held territory separating him from the relative sanctuary of the English Channel. Or, quite plausibly, it was the ingrained, unyielding tenacity characteristic of a seasoned fighter pilot, an indomitable refusal to abandon an aircraft that, despite its grievous wounds, was still, in the most technical sense, maintaining some semblance of flight, even if that term had become an exceedingly optimistic descriptor for its current precarious state. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. Following its second destructive sweep, the FW-190 disengaged, peeling away from the crippled Thunderbolt. Johnson, bracing himself for the inevitable coup de grace, anticipated a third decisive assault that would surely seal his fate. He endured an agonizing silence, waiting for 5 seconds, then 10, then 15, yet no further attack materialized. Cautiously, he risked a glance over his shoulder, peering through the spiderweb distortions of his shattered canopy, and observed the German fighter gracefully circling approximately 500 yards astern. The enemy aircraft was neither resuming its attack nor departing the scene. It merely maintained its position, a silent, predatory observer. In retrospective analysis, Johnson would later comprehend the tactical rationale of that particular Luftwaffe pilot. From his vantage point, the P-47 was unequivocally a spent force, its demise a foregone conclusion, already belching thick smoke and shedding fragments of its structure. There was no logical imperative to expend valuable ammunition on an adversary that was visibly destined to plummet from the sky of its own accord within a matter of minutes. Yet, against all rational expectations and the German pilot's calculated assessment, the Thunderbolt stubbornly refused to succumb. The formidable Pratt & Whitney R2800 engine, a colossal power plant, continued its arduous operation despite absorbing a multitude of direct cannon strikes in its accessory section. The critical oil pressure had plummeted to an alarmingly negligible level, while the coolant temperature soared far beyond the operational thresholds that should have undeniably resulted in a catastrophic engine seizure. Nevertheless, those 18 resilient cylinders persistently ignited, relentlessly rotating the propeller, and miraculously generating just sufficient thrust to sustain what could loosely be described as controlled flight. Johnson cautiously retarded the throttle, attempting to mitigate the severe thermal strain on the distressed engine, which responded with a guttural cough and a violent shudder, yet astonishingly did not cease its function. His most immediate and pressing challenge, however, was not the engine's impending failure, but rather the profound degradation of his aircraft's control. The crucial elevator cables had either been severed by enemy fire or irrevocably jammed by twisted metal, leaving him with virtually no authority over the aircraft's pitch. The rudder, having suffered partial destruction, afforded him perhaps a mere 20% of its normal yaw control. The ailerons, while technically still operational, functioned only marginally, and the compromised integrity of the right wing transformed any attempt at banking into an extremely hazardous gamble. Through painstaking, real-time experimentation, Johnson ascertained that he could maintain a semblance of level flight by continuously modulating engine power and meticulously manipulating the trim tabs. But any maneuver more assertive than the most delicate turn imperiled the aircraft, threatening to precipitate an uncontrollable spin or an outright structural collapse. Beyond the immediate existential threat to his aircraft's flight characteristics, a second formidable challenge emerged: navigation. His primary compass had been obliterated during the savage destruction of the instrument panel. His radio communication system was entirely defunct, and the intricate web of cracks across his canopy rendered familiar ground, landmarks utterly indistinguishable, transforming the world outside into an abstract, disorienting blur. While Johnson possessed a rudimentary understanding of England's general bearing, broadly west and slightly northward, any attempt at precise navigational plotting was utterly futile. He therefore selected a directional course based on the approximate angle of the sun and his internalized mental cartography of the French coastline, subsequently dedicating his entire focus to the arduous task of sustaining the Thunderbolt's flight for a sufficient duration to reach the relative safety of Allied territory. It was at this critical juncture that the plume of oil smoke emanating from the engine intensified dramatically. The power plant was, quite literally, incinerating itself from within. Internal metallic components were expanding catastrophically, beyond their engineered tolerances. Vital bearings were operating without lubrication, running completely dry, and the cylinder heads glowed with an ominous cherry-red incandescence behind the engine cowling. Johnson could now distinctly perceive the pungent aroma, the unmistakable scent of scorched oil commingling with superheated metal, and another unidentifiable but instinctively alarming odor. Each individual cylinder's combustion was nothing short of a minor engineering marvel, Every single rotation of that propeller represented precious, borrowed time. The few remaining operational gauges displayed readings that would have been dismissed as utterly unfeasible by the very engineers at Republic Aviation who designed the aircraft. An engine, by all conventional wisdom, simply should not operate under such extreme and compromised parameters. Yet, miraculously, it persisted. The remarkable, almost improbable survival of Johnson's P-47 ultimately hinged upon fundamental engineering decisions meticulously formulated 2 years prior within the design chambers of Republic Aviation on Long Island. These were strategic choices that, at the time of their conception, might have appeared overly cautious or even extravagant. Yet they proved to be nothing less than divinely fortuitous during this harrowing encounter high above the battlefields of France. Alexander Kartveli, the visionary chief designer at Republic, had conceived and developed the Thunderbolt based on an uncompromising philosophical tenet that many of his contemporaries in other aircraft manufacturing firms might have deemed inefficient or even profligate. His unwavering directive was to construct every single component with strength far exceeding its theoretical requirements, to incorporate robust redundancy wherever technically feasible, and, crucially, to never compromise the aircraft's inherent structural integrity in pursuit of mere marginal reductions in overall weight. The tangible manifestation of this design philosophy was an aircraft that, while admittedly weighing a substantial 3,000 pounds more than its agile German counterpart, the Messerschmitt Bf 109, possessed an unparalleled capacity to endure battle damage that would typically reduce lesser German fighters to splintered, plummeting wreckage. At the very heart of this extraordinary resilience lay the powerhouse itself, the magnificent Pratt & Whitney R2800 double wasp engine. This engineering marvel was an 18-cylinder radial engine, boasting a prodigious displacement of 2,800 cubic inches, and capable of unleashing an astounding 2,000 horsepower during critical war emergency power settings. Radial engines inherently conferred a distinct and undeniable advantage in terms of combat damage tolerance, a robustness that their inline engine counterparts simply could not replicate. The distinctive circular arrangement of its cylinders meant that the loss of even one, or indeed up to 3 cylinders due to hostile fire, still left a formidable contingent of 15 operational combustion chambers to propel the aircraft. In stark contrast, an inline engine, such as the Allison V1710 found in the P-40, or the venerable Merlin powering the Spitfire, consolidated all 12 of its cylinders within a narrow, linear block. This configuration meant that a single precisely aimed cannon shell could catastrophically crack the engine block or sever the crankshaft, thereby instantly incapacitating the entire power plant. Johnson's specific engine, a testament to its extraordinary durability, had absorbed no fewer than 6 direct impacts, 3 of which were devastating 20mm cannon shells that had violently penetrated the accessory case, utterly demolishing the vital oil pump housing. In any conventional scenario, the complete loss of oil pressure would invariably precipitate an irreversible engine failure within a mere 90 seconds, as critical bearings would seize and pistons would fuse inextricably to the cylinder walls due to extreme friction and heat. However, the R2800's immense thermal mass and its inherently rugged construction afforded Johnson precious time. The engine was, in essence, engaged in a self-destructive process, Yet this degradation was unfolding gradually. Each agonizing revolution relentlessly abraded internal metallic components and generated an escalating inferno of heat that simply could not be effectively dissipated. It was indeed expiring, but at a protracted pace measured in minutes rather than the instantaneous collapse of seconds. The aircraft's airframe itself was a masterclass in resilient design, incorporating a level of structural redundancy conspicuously absent in many contemporary fighter designs. Republic Aviation had meticulously engineered the P-47 around an exceptionally robust internal framework. This comprised heavy-gauge longerons, extensively reinforced bulkheads, and a primary wing spar engineered to withstand operational loads far surpassing the stresses encountered during typical flight conditions. This deliberate overkill in construction undeniably contributed to the aircraft's considerable weight, yet it simultaneously forged an inherently damage-tolerant structure, where the severance of a single load-bearing pathway did not automatically trigger an instantaneous and catastrophic structural collapse. For instance, Johnson's right wing had sustained a direct hit from a 20mm shell, which utterly obliterated a substantial 6-foot section of its rear spar. Despite this critical damage, the remaining front spar and the external skin of the wing collectively managed to bear sufficient aerodynamic load to prevent the wing from detaching entirely. A more lightly constructed airframe would, without question, have succumbed and folded immediately under such duress. The P-47's control system similarly exhibited this profound commitment to redundancy. Its vital control cables were meticulously routed through heavily armored channels and employed a dual cable configuration for all critical flight surfaces. Consequently, when enemy cannon fire severed Johnson's primary elevator cables, a set of backup cables miraculously retained sufficient, albeit significantly diminished, control authority. The system was undeniably compromised, operating at a barely functional capacity, yet it proved just adequate enough to permit the pilot to maintain the aircraft's trajectory in a direction that broadly approximated his intended course. This robust design stands in stark contrast to the Focke-Wulf 190, which, despite its overall sophistication, relied upon a considerably more vulnerable hydraulic control system. A single unfortunate strike to a hydraulic line invariably resulted in the total and immediate loss of control for the affected flight surface. Even the critical fuel system bore the indelible stamp of Cartveli's meticulously cautious, almost paranoid design philosophy. The P-47 housed its volatile fuel reserves within innovative self-sealing tanks, which were further safeguarded by robust armor plating and strategically positioned within the airframe to inherently minimize the perilous risk of fire. These specialized tanks incorporated a groundbreaking rubber compound, ingeniously developed by the U.S. Rubber Company, which possessed the remarkable property of expanding and effectively sealing itself upon contact with aviation fuel. This ingenious mechanism ensured that any bullet holes inflicted by enemy fire would be rapidly occluded, preventing substantial fuel loss. Johnson's particular aircraft, for instance, had endured multiple machine gun rounds piercing its left main fuel tank, yet, true to its design, the self-sealing mechanism functioned flawlessly. The punctures swiftly closed, the critical loss of fuel was arrested, and the ever-present danger of a catastrophic fire remained, against all odds, entirely manageable. The inherent dangers of the situation, while significant, were kept within controllable limits. The protective canopy, which had been struck and marked extensively by enemy cannon fire but had not disintegrated, was constructed from laminated bulletproof glass. This robust material, measuring 3/4 of an inch in thickness, possessed the formidable capability to withstand armor-piercing projectiles up to .50 caliber. The particular 20mm shell that struck Johnson's aircraft impacted at a slanting or indirect trajectory, thereby dispersing the immense force of the impact over a broader expanse of the surface. Consequently, the specialized glass developed cracks, yet it remarkably maintained its structural integrity, with its multiple laminated layers effectively hindering the kind of catastrophic shattering that would have propelled lethal plexiglass fragments directly into Johnson's facial area and eyes. In stark contrast, typical German fighter aircraft were equipped with conventional plexiglass canopies, which, despite being lighter and more cost-effective to produce, afforded absolutely no ballistic defense whatsoever against incoming fire. Furthermore, the engineers at Republic Aviation had meticulously designed the P-47 Thunderbolt with the foresight of potential battle damage, strategically positioning its most critical operational systems. Essential components, such as the radio apparatus, the intricate electrical network, and the hydraulic fluid reservoirs, were deliberately dispersed across various sections of the fuselage, rather than being consolidated into a single, highly susceptible point. In Johnson's harrowing predicament, his aircraft's hydraulic capabilities had been completely neutralized, his radio communications unit utterly obliterated, and fully half of his electrical power grid rendered inoperative. Nevertheless, the vital engine ignition system remarkably continued to function, drawing power from a distinct and independently routed electrical bus that had fortuitously remained intact. Moreover, the magnetos, which were responsible for generating the electrical impulses to fire the spark plugs, were directly driven by the engine itself, operating entirely independently of the aircraft's primary electrical system. This ingenious layer of redundancy proved to be yet another critical design feature that ensured the engine continued its operation even as numerous other vital systems succumbed to the devastating effects of combat. This robust and survivability-focused design ethos, however, incurred significant expenses that were typically viewed with disdain by financial auditors during periods of peace. The construction of a single P-47 Thunderbolt necessitated an extensive commitment of 5,500 man-hours, a considerable increase when contrasted with the 4,000 man-hours required for its contemporary, the P-51 Mustang. Furthermore, the Thunderbolt's manufacturing process consumed greater quantities of aluminum, steel, and various other specialized and more exotic materials. Consequently, the individual unit cost for a P-47 escalated to $85,000, substantially higher than the $51,000 price tag of a Mustang. Yet, as Johnson navigated the embattled skies above France, his aircraft riddled with an estimated 200 bullet holes, his very survival hanging precariously on the inherent strength of its structural margins and the reliability of its redundant systems, he was undeniably experiencing the profound and ultimate justification for those additional 1,500 man-hours of labor and the extra $34,000 investment. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. The Thunderbolt, while perhaps not aesthetically pleasing, nor exceptionally efficient in its operational metrics, nonetheless persisted in flight, defying all logical expectations that suggested it should have disintegrated into debris strewn across the French countryside. The staunch confidence held by the Luftwaffe in their ability to effectively eliminate P-47s was a direct consequence of an 18-month period marked by devastatingly successful engagements against previous generations of American fighter aircraft. Upon the initial deployment of P-38 Lightnings over the European theater in late 1942, German aviators swiftly pinpointed several critical vulnerabilities. The distinctive twin-engine configuration of the Lightning often meant that even a single engine strike could precipitate an uncontrollable yaw, while its Allison engines frequently suffered from overheating issues and catastrophic failures at higher altitudes. Consequently, pilots flying the formidable FW-190s devised a consistent and effective tactical maneuver. They would intentionally target one of the P-38's engines, observe the stricken aircraft twist uncontrollably into a spiraling descent, and then proceed to engage their next unfortunate adversary. By the spring of 1943, intelligence dispatches originating from Luftwaffe squadrons had formally categorized the P-38 as a primary engagement objective, noting its significantly high probability of destruction in combat. The P-40 Warhawk, regrettably, performed even more poorly in the demanding European aerial environment. Originally conceived and engineered for low-altitude engagements in the North African and Pacific theaters, the P-40 found itself decisively outmatched across virtually every performance metric by the advanced German fighter aircraft models of 1943. Luftwaffe pilots, in fact, barely perceived them as credible threats. Its Allison engine was incapable of generating sufficient power at altitudes exceeding 15,000 feet. Moreover, the aircraft's airframe proved inherently fragile when subjected to the rigors of sustained combat stress, meaning that battle damage, which a P-47 would readily absorb and continue flying, would inevitably send a P-40 plummeting earthward, leaving a telltale plume of smoke and flames in its wake. German after-action summaries from operations conducted in Tunisia and Sicily during early 1943 meticulously recorded P-40 kill ratios that significantly exceeded 3:1 in favor of the German forces. As P-47s began to deploy in substantial numbers throughout April 1943, the tactical analysis officers within the Luftwaffe formulated what appeared to be entirely logical presumptions, grounded in the intelligence available at the time. Their assessment indicated that the Americans had introduced yet another formidable heavyweight fighter, an aircraft notably larger and more ponderous than any other currently in operation, propelled by an enormous radial engine. German intelligence operatives accurately identified the formidable Pratt & Whitney R-2800 engine and proceeded to compute power-to-weight ratios, which strongly intimated a deficiency in the aircraft's maneuverability capabilities. Initial engagements in combat swiftly corroborated these preliminary forecasts. P-47s consistently demonstrated an inability to match the turning performance of the agile FW-190s, struggled to ascend at the same rates as the nimble Bf-109Gs, and conspicuously appeared to shun low-altitude dogfights altogether. Consequently, Jagdgeschwader II and JG-26, the elite Luftwaffe formations, tasked with the aerial defense of occupied France and the Low Countries, promptly revised their tactical doctrines to incorporate these observations. Their offensive briefings placed significant emphasis on capitalizing upon the P-47's subpar handling characteristics at lower airspeeds and exploiting the considerable blind spots inherent in the design of its distinctive razor-back canopy. The prescribed engagement strategies advocated for aggressive diving attacks, executed from superior altitudes and from positions astern of the P-47s. This approach leveraged the inherent advantage of height to accumulate significant speed, followed by a swift disengagement before the Thunderbolt could effectively deploy its substantial armament. This tactical methodology proved remarkably effective. The months of April and early May 1943 witnessed a consistent pattern of P-47 losses directly attributable to these well-coordinated bounce attacks. Furthermore, German pilots observed a recurring vulnerability in the P-47s concerning damage to their engines. The expansive radial engine of the P-47 presented an exceptionally large target profile, and in stark contrast to the inline engines that were typically nestled behind sleek aerodynamic cowlings, the cylinders of the R-2800 were conspicuously exposed to direct enemy fire. Consequently, armament specialists within the Luftwaffe advised concentrating firepower directly upon the engine during head-on engagements, utilizing the potent MG-151 1-poked 20mm cannon, which was typically loaded with a lethal combination of armor-piercing and high-explosive incendiary ammunition. The underlying theory behind this recommendation was that even if an immediate destruction of the aircraft was not achieved, significant engine damage would compel the P-47 to disengage from combat and return to base, effectively neutralizing its presence in the ongoing aerial conflict. What the German intelligence apparatus critically failed to comprehend was the profound, fundamental distinction in the construction philosophy of the P-47 compared to every other Allied fighter aircraft they had previously engaged. The Luftwaffe had accumulated vast operational experience in successfully destroying enemy aircraft that had been manufactured under the constraints of peacetime weight restrictions and limitations on available materials. For instance, British Spitfires and Hurricanes, while remarkably efficient in their aerodynamic design, relied upon relatively lightweight structural frameworks. Soviet fighter aircraft were notoriously delicate, occasionally incorporating plywood elements into their construction to conserve more strategic metals. Even the P-38 Lightning, despite its dual-engine configuration, was engineered with a primary objective of minimizing overall weight to optimize its performance characteristics. The P-47, however, originated from an entirely divergent design philosophy, one made feasible by the immense industrial capacity of the United States and a deliberate readiness to embrace significant weight penalties in exchange for unparalleled combat survivability. Luftwaffe pilots possessed absolutely no prior experience or frame of reference for an aircraft capable of enduring 50 or even 60 direct hits and still continuing to engage in combat. Their accumulated operational knowledge dictated that such an extensive degree of damage invariably resulted in catastrophic structural failure, an uncontrollable fire, or an immediate, unavoidable, forced landing. The very notion of an aircraft intentionally engineered with excessive robustness to withstand extensive battle damage was entirely absent from their tactical planning and calculations. This significant conceptual blind spot permeated even to the highest echelons of the Luftwaffe leadership. Reichsmarschall Hermann Göring, a figure who himself possessed first-hand combat experience from the First World War, firmly held the conviction that an aircraft's ability to survive engagements stemmed primarily from the exceptional skill of its pilot and the deployment of aggressive, tactical maneuvers, rather than from inherent structural redundancy. Consequently, the Luftwaffe had consistently designed and constructed its fighter aircraft to be lightweight and exceptionally fast, willingly accepting a higher rate of losses as a trade-off for superior performance advantages. When intelligence dispatches began to circulate, highlighting instances where P-47s were surviving aerial encounters that, by all conventional standards, should have proven fatal, the initial reaction within the Luftwaffe was one of profound skepticism. The prevailing sentiment suggested that German pilots were likely exaggerating the number of hits they had scored, or that American aviators were simply benefiting from an extraordinary streak of luck. Major Gerhard Schöpfel, a distinguished high-scoring ace who commanded the 3 JG-26 unit, submitted a detailed report in late May 1943. In this account, he vividly described an aerial engagement during which he estimated he had delivered approximately 40 rounds into a P-47. Yet he failed to observe the aircraft crash. His commanding officers, however, expressed doubts regarding the precision of his evaluation, positing that the intense pressures of combat frequently caused pilots to exaggerate the actual number of successful hits. Schöpfel steadfastly maintained the veracity of his observations. He argued that the P-47 had undeniably sustained numerous direct cannon strikes, and although it had been visibly emitting a trail of smoke, it had remarkably preserved controlled flight for a sufficient duration to successfully flee across the English Channel. The institutional self-assurance of the Luftwaffe persisted at a high level throughout May 1943, primarily because the statistical data available at the time appeared to validate their tactical approaches. They were indeed downing P-47s at rates that, while not as overwhelmingly advantageous as those achieved against the P-40s, nonetheless constituted acceptable exchange ratios from their perspective. What they critically failed to discern, however, was that they were inadvertently observing a phenomenon of selection bias. The P-47s that they successfully destroyed were invariably those that had suffered catastrophic hits directly to the pilot or experienced critical single-point system failures. Conversely, the aircraft that managed to survive with extensive damage were not being recorded in German loss assessments, simply because they were not crashing on the French side of the Channel, thus disappearing from enemy observation. Johnson's battered aircraft traversed the French coastline at a precarious altitude of barely 8,000 feet. The formidable Thunderbolt was steadily relinquishing altitude at an approximate rate of 200 feet per minute, notwithstanding his most strenuous endeavors to sustain level flight. The engine, clearly operating on borrowed time, was exhibiting a rapidly deteriorating mechanical integrity. Its cylinder head temperatures had soared to such extreme levels that the indicator needles on the gauges were firmly lodged beyond their maximum calibrated readings. With alarming regularity, every few seconds the engine would falter, emit a harsh cough, shudder violently, and then resume its strained, agonizing rotation. Johnson could distinctly perceive each individual misfire transmitting through the very structure of the airframe as a palpable vibration, and he instinctively understood that he was in a dire countdown toward an inevitable and complete engine failure. Beneath him, the vast expanse of the English Channel unfolded, a formidable 40 miles of frigid, slate-gray water that, considering the severely compromised state of his aircraft, felt as boundless and unforgiving as an entire ocean. Johnson meticulously performed the necessary mental calculations, and the resulting prognosis was grim and deeply unsettling. Factoring in his current descent rate of 200 feet per minute and a forward airspeed of 180 miles per hour, his trajectory indicated an unavoidable impact with the water, a full 15 miles shy of the safety of the English coastline. The Thunderbolt found itself approximately 15 miles shy of the English coastline. Conceptually, an emergency landing or ditching of a P-47 aircraft into turbulent waters offered a theoretical chance of survival. The fighter's robust and broad fuselage, coupled with its distinctive radial engine, inherently provided certain buoyant qualities. However, the crucial factor for a successful outcome hinged entirely upon the pilot retaining consciousness and escaping significant injury during the violent impact with the sea. In Johnson's precarious situation, this ideal was already severely jeopardized. He had sustained multiple shrapnel wounds. His visual acuity and depth perception were critically impaired by a severely fractured canopy, and the complete failure of his hydraulic system meant the landing gear could not be deployed, ensuring an unavoidable belly-first impact. With a sense of desperate futility, the pilot made another attempt to activate his radio, fully aware of its probable demise, yet clinging to a slender thread of hope that some vital circuit might have miraculously endured the damage. The only response was an oppressive cacophony of static, followed by an unnerving silence. This grim reality confirmed the absence of any means to contact air-sea rescue operations or to forewarn the Royal Air Force stations dotting the coastline that a critically damaged American fighter was approaching, almost certainly requiring urgent aid. He found himself utterly isolated, grappling with a mortally wounded aircraft, forced to make split-second decisions that would irrevocably dictate his fate, a comfortable night's rest in an English bed, or an indelible inscription on the somber rosters of those declared missing in action. Despite his meticulous and desperate attempts at mitigation, the engine's internal temperature continued its relentless ascent. Johnson had painstakingly throttled back the power to the barest minimum required for cruise flight, carefully adjusting the fuel mixture to its leanest permissible setting. However, the structural and mechanical integrity of the engine had been compromised beyond any hope of recovery. Within its depths, metal components were audibly grating against one another, bearings were seizing from a critical lack of lubrication, and pistons were mercilessly scarring the cylinder walls with each agonizing rotation. A pervasive, acrid scent began to permeate the cockpit, discernible even through his oxygen mask, the unmistakable stench of an engine slowly devouring itself. This noxious fusion of superheated metal and combusting oil was a universally recognized harbinger among aviators, signaling the imminent and catastrophic demise of the power plant. We invite you to stay with us and witness the gripping conclusion of this narrative. Your support through a like and subscription would be greatly appreciated. Please share in the comments where you are from and your thoughts on this incredible story of survival against overwhelming odds. Approximately 10 miles from the French coastline, a sudden and alarming irregularity manifested in the propeller's rotation. It began to windmill erratically. Johnson perceived this critical alteration instantly. Gone was the previous smooth, albeit struggling rotation, replaced by an unsettling pattern of the propeller blades catching and then releasing. indicative of an engine no longer capable of delivering consistent power. He instinctively manipulated the propeller pitch control, but his efforts were met with a complete lack of response. The vital hydraulic system responsible for governing the blade angle had been irrevocably destroyed, having been shot away during that perilous second pass over French territory. Consequently, the propeller was now locked into whatever pitch it had coincidentally settled into, an angle far from optimal for the meager power output the faltering engine could still generate. This critical juncture, Johnson executed a strategic decision that, in all likelihood, proved to be life-saving. Rather than stubbornly attempting to preserve altitude, only to inevitably succumb to the channel's unforgiving waters, he opted to embrace a controlled descent, shrewdly leveraging his remaining height to extend his forward progress. He deliberately guided the P-47 into a gentle dive, effectively exchanging precious altitude for a crucial increment in airspeed and ground covered. While this maneuver increased his descent rate to 400 feet per minute, it simultaneously boosted his ground speed to a rapid 220 mph. The severely damaged engine, however, protested against this heightened workload. Its internal temperatures surged even further, and the frequency of misfires became more pronounced, yet astonishingly it continued to function. With the French coast now only 5 miles astern, Johnson's altitude had dwindled to a precarious 4,000 feet. The grim calculations in his mind grew increasingly restrictive. Should the engine falter and cease functioning at this precise moment, he might conceivably reach the vast expanse of the Channel, but attaining the safety of England would be an absolute impossibility. The coastline, a distinct demarcation of cliffs and sandy beaches separating occupied Europe from the open sea, was now sharply visible. Each passing mile held profound significance, and every precious minute the beleaguered engine persevered was an unearned blessing, yet one he desperately required. The landmass slipped beneath his wings at precisely 13:47 hours, marking 32 harrowing minutes since the initial hostile engagement. At an altitude of 3,200 feet, Johnson's aircraft continued its inexorable descent, the engine now struggling to generate perhaps 60% of its rated power, and that output steadily diminishing. The vast expanse of the English Channel lay before him, and for the very first time since his Thunderbolt had absorbed those punishing hits, a flicker of hope ignited within Johnson. He permitted himself to believe that he might, against all odds, actually succeed in his perilous journey. The English coast, a faint, dark line on the distant horizon, lay approximately 30 miles away. Based on his current rate of descent and airspeed, the intricate calculations suggested a narrow margin, but a possibility nonetheless. Then, without warning, the engine catastrophically seized. There was no gradual decline, no premonitory coughs or sputters. Instead, one moment it was operating roughly, the next it was utterly locked solid. The propeller blades, halted abruptly mid-rotation, became rigid, immobilized by internal damage that had finally surpassed even the remarkable endurance of the R-2800 power plant. The ensuing silence was profoundly overwhelming. For the preceding half hour, Johnson had been subjected to the tortured symphony of the dying engine, its grinding protests and intermittent coughing having almost blended into a grim background noise. Now an eerie void of sound enveloped him, broken only by the mournful whistle of the wind rushing past the fuselage and the unsettling creak of the damaged airframe. At an altitude of merely 2,000 feet and still 28 miles distant from the English coast, Johnson found himself gliding precariously in a battle-scarred fighter, devoid of engine power, hydraulic systems, and possessing only marginal control authority. He rapidly performed the critical glide ratio calculations in his mind. Under optimal circumstances, the P-47 was notoriously poor at gliding, often likened to a flying brick, typically advancing approximately 8 feet horizontally for every foot of altitude sacrificed. However, factoring in the extensive battle damage and the immense drag generated by the now frozen propeller, he estimated a significantly reduced ratio, perhaps 6-to-1. To reach his objective, he required a staggering 28 miles, or approximately 147,840 feet, of glide distance. With only 2,000 feet of altitude remaining, he could muster, at best, perhaps 12,000 feet of available glide. The arithmetic was starkly unequivocal. It was an impossible equation. He was not going to make it. Against all logical aerodynamic predictions, Johnson miraculously reached the English coast at an astonishingly low altitude of 200 feet. The Thunderbolt's improbable glide was an extraordinary testament to a potent blend of sheer desperation and the pilot's incredibly minute, precise control inputs, which perpetually balanced the aircraft on the precipice of a stall. He had defied the laws of physics, traversing the final 15 miles of open water in a descent so incredibly shallow that it should have been aerodynamically unachievable. Yet, through some confluence of the P-47's expansive wing area and Johnson's profound instinctive mastery of energy management, he had meticulously extracted every conceivable foot of horizontal distance from the rapidly diminishing altitude at his disposal. With a breathtakingly narrow margin, perhaps a mere 50 feet of clearance, he successfully surmounted the iconic white cliffs, so close that he could distinctly observe individual seabirds scattering in alarm from the sheer rock face. The nearest Royal Air Force station within his reach was Hawkins, a modest fighter base situated near Folkestone, which had famously served on the front lines during the pivotal Battle of Britain some 3 years prior. Johnson possessed no functional radio to broadcast his plight, no emergency flares to signal his dire situation, nothing but a grievously wounded aircraft plummeting towards the tranquil English farmland at a blistering speed of 100 meters. 2 miles ahead, he discerned the familiar outline of the airfield, its grass runways meticulously arranged in the standard RAF triangular configuration. He immediately committed to a straight-in approach, recognizing that any possibility of a go-around was utterly non-existent. The predicament of his landing gear presented an immediate and intractable problem. Without any functional hydraulics, both the main gear and the tail wheel remained resolutely locked in their retracted positions. While P-47s were designed with the capability for a belly landing, a procedure meticulously detailed in the pilot's handbook and practiced by ground crews in training, the manual's instructions fundamentally presupposed a controlled approach, complete with fully operational flaps and adequate elevator authority. Johnson, however, possessed neither. His flaps, being hydraulically actuated, were utterly useless, and his elevator cables were partially severed, affording him a mere 20% of normal pitch control. Consequently, he faced the daunting prospect of a high-speed, nose-high landing, completely unable to execute a proper flare. Abandoning conventional procedures, Johnson initiated his approach guided almost entirely by raw instinct, making adjustments to the handful of systems that still responded to his commands. The inability to deploy his flaps meant his approach speed would be perilously elevated, likely around 140 mph as he crossed the runway threshold, a stark contrast to the standard 90 mph with flaps extended. He was also powerless to adjust the propeller, which remained rigidly locked in the pitch it had seized in, thereby generating an immense and detrimental drag. His mixture control was jammed, the throttle rendered completely irrelevant, without a functioning engine, and the majority of his instrument panel was obliterated. He was, in essence, flying by visual cues and intuitive feel, a primal method of aviation reminiscent of how pilots navigated and landed aircraft in the nascent days before the advent of sophisticated instrument panels. The duty officer at Hawking, observing the severely damaged P-47 on its final approach, instantly initiated an emergency response, scrambling the crash crew. Even from the ground, the aircraft's critical condition was unmistakably evident. Conspicuous holes marred its wings, a section of the tail was conspicuously absent, the canopy was fractured, and dark, ominous streaks adorned the fuselage, suggesting either pervasive oil leaks or scorch marks from fire. The sheer fact that such a crippled machine remained airborne defied all logic, appearing utterly impossible. Furthermore, the pilot's audacious decision to attempt a landing rather than bailing out struck observers as nothing short of an act of sheer madness. Johnson breached the airfield boundary at a mere 100 feet, the P-47 descending more rapidly than he desired, yet still maintaining a semblance of control, albeit by the most generous definition of the term. He gently pulled back on the control stick, endeavoring to mitigate the rapid descent, but the aircraft responded with a distinct sluggishness. The ground surged upwards with alarming speed, the familiar grass fields abruptly yielding to the meticulously mowed runway surface. At this precise moment, Johnson grasped with absolute clarity the undeniable reality he was going to impact the Earth with immense force. In a desperate final effort, he yanked the stick back as far as its travel would permit, the compromised elevator cables straining taut, and the Thunderbolt's nose pitched up by perhaps 5 degrees, just enough to transform what would have been a catastrophic impact angle into one that was merely brutal. The P-47 made contact with the grass runway, belly first, at an astonishing speed of 135 mph. The resulting impact was both instantaneous and profoundly violent. 7 tons of aircraft underwent a brutal deceleration, transitioning from highway speed to a complete halt within a mere 400 yards. The aircraft's belly skin ripped away in ragged strips, a cacophony of grinding metal against earth and grass, creating a sound that eyewitnesses later struggled to describe, placing it somewhere between the deafening roar of thunder and the catastrophic derailment of a freight train. A geyser of dirt and debris erupted around the fuselage, the propeller blades digging deep into the soil, bent grotesquely backward. The right wing flexed sharply upwards, its compromised spar finally succumbing under the immense impact loads. For a fleeting moment, it appeared as though the entire wing would detach, yet it stubbornly remained connected. The Thunderbolt continued its harrowing, plowing motion across the grass, shedding components and momentum in equal measure, leaving a dramatic rooster tail of churned earth and aviation fuel in its wake. The P-47 Thunderbolt skidded to a violent halt, kicking up a colossal plume of earth and highly volatile aviation fuel. Inside the cockpit, Johnson was violently propelled forward, his torso straining against the unyielding shoulder straps of his harness. which cruelly abraded skin already tender and weeping from the earlier shrapnel wounds. His head, flung uncontrollably, collided with devastating force against the gun sight, instantly tearing open a deep laceration above his right eye, which promptly obscured his sight with a warm crimson flow. The profound deceleration seemed to stretch into an eternity, an overwhelming sensation akin to being relentlessly squeezed by unseen colossal forces. Each internal organ felt excruciatingly compacted against his skeletal structure, his lungs involuntarily expelling their contents in a gasp. Ultimately, the battered warplane ceased its destructive slide precisely 380 yards from the point of its initial jarring contact with the ground. It lay generally parallel to the runway's axis, though undeniably skewed at a distinct 15-degree angle to the right, a consequence of the critically compromised wing having deeply gouged into the terrain. A profound, almost deafening silence enveloped the scene, punctuated solely by the subtle rhythmic ticking sounds emanating from the rapidly cooling metal of the engine and fuselage, and the increasingly discernible wail of approaching fire trucks, their sirens growing louder with each passing second. Within the confining confines of the cockpit, Johnson remained motionless, momentarily incapable of fully comprehending the astonishing reality that he was, against all odds, alive and on English soil. His hands remained rigidly clamped onto the control stick and throttle, his muscles severely cramped and aching from the relentless, vice-like grip he had exerted for the preceding 45 minutes of harrowing flight. The aircraft's canopy, a crucial escape route, was irrevocably jammed, its structural frame grotesquely distorted by the immense forces unleashed during the impact. Johnson desperately attempted to activate the emergency jettison mechanism, but it yielded no response whatsoever. There were no hydraulics functioning, no compressed air backup systems engaging, simply an absolute void. He was now utterly confined within the mangled fuselage of a wrecked aircraft, acutely aware that it could erupt into flames at any given moment, with aviation fuel and lubricating oil ominously saturating the intensely hot metal components. We urge you to stay with us and witness the compelling conclusion of this video. We would be profoundly grateful for your valuable like and subscription to our channel. Please also take a moment to share in the comments where you are from and your thoughts on the intriguing topic presented in this video. Remarkably, the dedicated crash crew descended upon the beleaguered P-47 with incredible swiftness, arriving within a mere 90 seconds of the aircraft's final stop. Firefighters, equipped with an array of heavy-duty axes and formidable crowbars, swarmed over the fuselage, vigorously assailing the twisted canopy frame with specialized implements engineered precisely for the arduous task of extricating pilots from severely damaged fighter planes. With a final strenuous heave, they managed to pry the canopy open, and Johnson, overcome by exhaustion and injury, virtually tumbled out, his legs seizing up painfully from significant blood loss and the profound effects of shock. A waiting medical officer deftly intercepted him, gently guiding him to the ground, and immediately began a comprehensive assessment of his injuries, all, while Johnson, with an almost obsessive repetition, reiterated the same urgent plea, "Count the holes. You need to count the holes." Initially, the medical officer surmised that Johnson's insistent demand stemmed from a state of delirium induced by profound shock. However, Johnson firmly grasped the officer's arm, repeating his request with such compelling intensity that the medical professional recognizing the gravity of the pilot's state, nodded in affirmation, and reassured him that the ground crew would indeed undertake a thorough and comprehensive damage assessment. The unenviable task of conducting this vital inspection fell to Staff Sergeant Arthur Williams, an exceptionally seasoned armorer and ground crew chief who possessed an intimate familiarity with maintaining fighter aircraft, a role he had performed diligently since well before the outbreak of hostilities. Williams had witnessed countless battle-scarred aircraft hobble back from perilous missions over France, including P-47s bearing the scars of anti-aircraft flak, the precise punctures of machine gun fire, and even the devastating impact of several cannon rounds. Yet when he commenced his meticulous walk-around inspection of Johnson's Thunderbolt on the afternoon of May 26th, his usual methodical counting ceased abruptly after scrutinizing just the first wing panel, prompting him to immediately seek out his commanding officer. The following morning, on May 27th, a formal and meticulously documented assessment was undertaken, complete with extensive photographic evidence. Williams arrived accompanied by 2 assistants, carrying a clipboard laden with specialized grid sheets, meticulously designed to precisely map the myriad damage locations onto standard P-47 diagrams. Their systematic examination commenced at the aircraft's nose and proceeded methodically backward, diligently marking every single perforation, every jagged tear, and every area where German bullets and shells had ruthlessly breached the integrity of the airframe. This exhaustive process consumed a full 4 hours. The conclusive tally revealed an astounding 203 distinct impact points, a figure so profoundly high that Williams initially found it impossible to accept, compelling him to meticulously recount the damage not once, but twice, to ensure absolute verification. The intricate pattern of destruction, meticulously documented on the aircraft's surface, served as a detailed, almost forensic narrative of Johnson's harrowing engagement. The right wing alone had sustained a staggering 68 direct hits, with the majority of these impacts densely concentrated within a 6-foot section, where a powerful 20mm cannon shell had catastrophically detonated deep within the main spar. This violent internal explosion had utterly obliterated significant portions of the internal structural components, leaving the wing's outer skin hanging precariously in shredded strips. Astonishingly, despite such extensive damage, the crucial front spar had miraculously retained sufficient structural integrity to prevent the entire wing from tearing away. Furthermore, 3 distinct penetrations of the fuel tanks were clearly observable, each conspicuously encircled by the characteristic swelling of the self-sealing compound, a vital mechanism that had successfully sealed the breaches and thereby averted any critical loss of precious aviation fuel. Moving along the main body of the aircraft, the fuselage presented an equally alarming sight, displaying an astonishing 114 discrete impact points extending from a position directly aft of the engine all the way to the tail section. Numerous projectiles had pierced entirely through both sides of the fuselage, entering from one flank and exiting from the other, after tearing through the aircraft's vital internal framework. In one particularly chilling instance, a 20mm shell had penetrated the airframe a mere 18 inches behind the cockpit, then traveled forward at a perilous angle before lodging itself, unexploded, within the sensitive radio equipment bay. The ordnance disposal team, tasked with its delicate removal later, unequivocally confirmed it to be a high explosive round that had, by some inexplicable stroke of fortune, simply failed to detonate. It was an act of pure, unadulterated luck that had prevented the warhead from simultaneously obliterating both the cockpit and the pilot within. The damage inflicted upon the tail section was so profoundly extensive that Staff Sergeant Williams, in his initial professional judgment, categorized the aircraft as being beyond economical repair. The vertical stabilizer alone bore the scars of 21 distinct perforations, among which 3 were gaping holes that had removed substantial portions of the rudder, large enough to afford clear visibility through them. Both horizontal stabilizers exhibited 16 hits apiece, with one elevator rendered almost entirely useless. Astonishingly, this was the very same elevator that Johnson had managed to manipulate to maintain control of the aircraft during his desperate landing maneuver. The persistence of any discernible control authority whatsoever was unequivocally ascribed to the P-47's ingenious redundant cable routing system, a design feature that ensured partial functionality even when crucial primary control cables had been completely severed. The aircraft's powerful R-2800 engine presented its own incredible testament to mechanical impossibility. Upon removal of the cowling, Williams and his dedicated team discovered an engine unit that appeared as though it had been subjected to sustained target practice. 3 of its cylinders had sustained direct hits, one so grievously damaged that the piston itself was plainly visible through a gaping aperture in the cylinder wall. The accessory case lay completely shattered, the vital oil pump was utterly destroyed, and the magneto housing displayed impact damage that, by all engineering logic, should have resulted in an immediate and complete cessation of ignition. Nevertheless, against all conceivable odds, this mangled engine had somehow persevered, continuing to operate for an astonishing 32 minutes after the initial onslaught, miraculously generating sufficient power to sustain Johnson's flight across a treacherous 50 miles of hostile airspace and unforgiving open water. In early June, Alexander Kartveli, the distinguished chief engineer at Republic Aviation, received the comprehensive damage assessment report, accompanied by a collection of photographs that he initially presumed to be artful composites, illustrating damage sustained by multiple aircraft. However, upon receiving unequivocal confirmation that all the depicted destruction originated from a singular P-47, Kartveli promptly submitted a formal request for the aircraft to be meticulously prepared and shipped back to the Republic factory located in Farmingdale, New York, for an exhaustive engineering analysis. This extraordinary request was duly approved, and Johnson's P-47, bearing the serial number 428487, subsequently undertook the arduous Atlantic crossing nestled within the cargo hold of a ship, thereby returning home not as a formidable combat weapon, but as an invaluable test specimen for further study. By mid-June 1943, the 8th Air Force had widely disseminated the detailed damage assessment report to all P-47 fighter groups stationed throughout England. This crucial report encompassed Staff Sergeant Williams' evocative photographs and also incorporated a thorough technical analysis provided by Republic's expert engineering team, which lucidly elucidated the extraordinary reasons for the aircraft's improbable survival. Group commanders strategically utilized this compelling documentation during pilot briefings, presenting irrefutable, concrete evidence that the P-47 possessed an unparalleled capacity to absorb a level of battle damage that would undoubtedly have obliterated any other fighter aircraft operating within the European theater. the resultant psychological impact on the pilots was nothing short of profound. Aviators who had previously harbored doubts regarding their aircraft's resilience now possessed tangible proof that the formidable Thunderbolt genuinely lived up to its formidable reputation for toughness. Within a mere 2 weeks, intelligence concerning Johnson's miraculous survival had permeated thoroughly through the intricate networks of the Luftwaffe. German pilots conducting operations over the English Channel had observed the heavily smoking P-47 making its way across the coast and had, quite reasonably, presumed that it would crash shortly thereafter, a perfectly standard outcome for an aircraft sustaining such catastrophic damage. However, when intercepted radio communications and subsequent interrogations of captured prisoners of war unequivocally confirmed that not only had the pilot endured, but the aircraft had also been successfully landed, Luftwaffe tactical analysis officers were compelled to embark upon a fundamental reassessment of their established engagement doctrines. These unsettling reports eventually reached Major Gerhard Schöpfel, a prominent figure at Jagdgeschwader 26, JG 26, in late June, coinciding with a period when other German pilots were also submitting similar accounts detailing P-47s, absorbing what should have been unequivocally fatal damage, yet still managing to evade destruction. Schöpfel, recognizing the paradigm shift, promptly revised his tactical briefings to accurately reflect this stark new reality. The P-47 was unequivocally not an easy target to dispatch. Consequently, attacks against these formidable American fighters needed to be executed with far greater precision, specifically targeting critical vulnerabilities, and German pilots were explicitly cautioned against assuming that merely visible damage signified an imminent crash. Furthermore, the recommended ammunition load underwent a significant alteration, transitioning from a mixed complement of armor-piercing and high-explosive rounds to a substantially higher proportion of armor-piercing ammunition, specifically designed to penetrate deeply into vital internal systems rather than merely inflicting spectacular yet ultimately non-fatal surface damage. By August 1943, Luftwaffe doctrine had evolved to explicitly caution against disengaging from attacks on damaged P-47s unless the American fighter was unequivocally observed to be ablaze or in an uncontrollable spiraling descent. German pilots were now under strict instructions to pursue damaged Thunderbolts across the treacherous English Channel, provided their fuel reserves allowed, specifically to confirm actual crashes rather than merely claiming probable kills based solely on superficial, visible damage. This profound shift in operational directives represented a fundamental metamorphosis in German tactical thinking, a change directly impelled by the mounting, irrefutable evidence that American engineering prowess had successfully produced a fighter aircraft that operated according to an entirely different set of rules than anything they had previously encountered in aerial combat. Johnson, against all expectations, made his return to active combat operations on June 13, 1943, a mere 18 days subsequent to the mission that, by all rational measures, should have claimed his life. The 56th Fighter Group promptly assigned him a brand new P-47, and he piloted this machine with an unmistakable air of confidence that was immediately apparent to his fellow aviators. There exists a profound psychological metamorphosis that often occurs within a pilot who endures something truly unsurvivable. This experience either utterly shatters their spirit leaving them irrevocably broken, or conversely, it forges within them a unique, almost aggressive fearlessness, firmly predicated upon a newly acquired, proven sense of invincibility. Johnson, without a shadow of a doubt, unequivocally fell into the latter, more resilient category. The pilot in question, whose name has become synonymous with aerial fortitude, found himself in that latter astonishing category of survivors. He had endured an extraordinary maelstrom of enemy fire, his aircraft riddled with countless projectiles. Yet he had miraculously lived to tell the tale. The formidable German Luftwaffe had unleashed its most destructive efforts, attempting to obliterate his machine. But he had, against all odds, managed to guide his severely damaged fighter back to the safety of England. This particular aircraft, which many critics had previously dismissed as excessively heavy, somewhat sluggish in maneuver, and inherently vulnerable, had absorbed an astonishing 203 direct hits from enemy ordnance and, through sheer structural integrity, had delivered its pilot safely home. The immense, almost mythical confidence stemming from this incredible feat permeated swiftly through the ranks of the 56th Fighter Group and radiated outwards across the entire American 8th Air Force. Pilots who had, until then, been cautiously exploring the limits of the P-47, Thunderbolt's capabilities now felt emboldened. They pushed their machines harder, committed to aerial engagements for extended durations, and willingly embraced risks they would have previously deemed unacceptable or outright suicidal. The profound realization that their aircraft possessed an unparalleled capacity to absorb tremendous punishment and yet remain airborne fundamentally recalibrated their tactical assessments. Where a P-47 pilot might have instinctively disengaged after sustaining even a few hits, they now meticulously evaluated the extent of the damage, and if critical systems remained operational, frequently chose to stay locked in combat. The Thunderbolt thus transcended its mere function as a fighting machine. It had evolved into a potent psychological instrument, imbuing American pilots with a newfound courage that the German Luftwaffe simply could not fathom or counter. The pilot himself, through his extraordinary survival, became a living testament, a tangible embodiment of Republic Aviation's robust engineering prowess, serving as a walking advertisement for their design philosophy. By the conclusion of the war, he had amassed an impressive tally of 27 verified aerial victories, firmly establishing himself as one of the preeminent American aces within the European theater of operations. His distinguished career saw him complete 91 demanding combat missions, and remarkably, he endured being shot down on yet another occasion, once again while piloting a P-47. And once more, he returned to base without injury. His resilience and the Thunderbolt's durability were inextricably linked in the minds of his comrades. Other aviators, eager to glean insights from his incredible experiences, actively sought his counsel, inquiring about the specific techniques and mental fortitude that had enabled him to guide that severely perforated Thunderbolt across the treacherous English Channel. His response, delivered with consistent conviction, always remained the same. Place your unwavering trust in the aircraft, possess an intimate understanding of its systems, and never under any circumstances abandon a P-47 until it has been physically rendered incapable of flight. We sincerely hope you are enjoying this detailed exploration. Please stay with us until the very end of this narrative and consider showing your appreciation by giving us a like and subscribing to our channel. We would also be truly grateful if you could share where you are from and offer your thoughts on the compelling topic of this video in the comments below. The widespread repercussions on American fighter operations became demonstrably quantifiable by the latter half of 1943. The P-47 loss rates, measured per sortie, witnessed a significant decline from the concerning elevations observed during April and May, stabilizing at approximately 1.2% by September, even as the overall intensity and frequency of aerial combat markedly increased. While a portion of this encouraging improvement was attributable to the accumulation of pilot experience and the refinement of combat tactics, a substantial segment of this reduction in losses was directly linked to pilots electing to remain with their damaged aircraft rather than bailing out prematurely. Airframes that, under previous operational doctrine, would have been immediately classified as irrecoverably lost, instead managed to limp back to airfields in England, subsequently underwent thorough repair, and were efficiently returned to active combat duty. This remarkable shift effectively augmented the operational strength of the 8th Air Force's fighter arm without the need to introduce a single new aircraft. The increase stemmed purely from their enhanced ability to salvage and restore a greater number of damaged machines to flying condition. Republic Aviation, recognizing the immense value of this extraordinary incident, extensively leveraged the pilot's survival in their various training materials and technical documentation. The company meticulously produced a comprehensive case study detailing the 203 hit incident, subsequently distributing it widely to military procurement offices across the Allied nations and to all Allied air forces. This meticulously compiled documentation served a crucial dual purpose. It unequivocally validated Republic AS's foundational design decisions, particularly regarding robust construction, and simultaneously provided concrete, irrefutable evidence for the inherent value of such heavy-duty engineering, even when it entailed the trade-off of additional weight and increased manufacturing expense. When critics raised legitimate questions about why the P-47 incurred significantly higher costs than other contemporary fighter aircraft, Republic could powerfully counter by presenting photographs of the pilot battle-scarred aircraft, posing the rhetorical question of what ultimate price anyone would place on the invaluable survival of a pilot. The German Luftwaffe, as subsequent recalibration of its tactical approaches, specifically in response to the P-47 as unprecedented durability, initiated a profound and cascading effect throughout German fighter operations during the latter months of 1943. Pilots who had previously engaged Thunderbolts with a degree of unwarranted confidence now approached these American fighters with palpable caution, having learned through bitter experience that merely riddling a P-47 with bullets did not automatically guarantee a confirmed kill. This newfound German circumspection directly translated into protracted engagement times, which consequently meant that German fighters had less available time to dedicate to attacking the vulnerable bomber formations, ultimately leading to improved survival rates for Allied bombers. The P-47's burgeoning reputation as an almost indestructible damage sponge began to exert its psychological influence even before the first shots were exchanged. German pilots were increasingly compelled to commit greater resources, expend more ammunition, and undertake substantially higher risks to achieve kills that they had, in earlier encounters, secured with relative ease. Quantitative evidence of this impact is vividly illustrated by German ammunition expenditure statistics derived from Luftwaffe quartermaster reports. In April 1943, the average number of rounds expended to achieve a single P-47 kill stood at approximately 220 for 20mm cannon and 850 for machine guns. By October 1943, these figures had dramatically escalated, climbing to 380 cannon rounds and a staggering 1,400 machine gun rounds per confirmed P-47 kill. German pilots, while undoubtedly shooting more frequently and achieving more hits, were requiring a significantly greater volume of impacts to achieve the same destructive result. This burgeoning inefficiency inexorably cascaded through the entire Luftwaffe supply chain, placing an immense strain on ammunition production facilities and logistical networks, occurring precisely at a time when the strategic bombing campaign was intensely targeting those very same industrial systems. The profound psychological dimension of the P-47's resilience also extended to the Allied bomber crews. Gunners aboard B-17s and B-24s could witness their P-47 escorts absorb visible and often extensive battle damage, yet continue to fight valiantly. A sight that significantly boosted morale during the terrifying deep penetration bomber runs into the heart of Germany. Prior to mid-1943, fighter escorts that sustained hits typically broke off from the formation and headed for home, leaving the vulnerable bombers exposed to relentless enemy attacks. The reassuring spectacle of shot-up Thunderbolts stubbornly remaining in the fray, continuing to engage German fighters even while trailing plumes of smoke, instilled a vital sense of confidence in the bomber crews that their escorts would not abandon them at the first sign of trouble or danger. The pilot, its remarkable story, swiftly ascended into the realm of 8th Air Force legend, recounted and retold countless times in ready rooms and mess halls across England. New replacement pilots, freshly arrived from the United States, heard the awe-inspiring tale of the 203-hit Thunderbolt even before they embarked on their inaugural combat mission. This powerful narrative served a dual purpose. It acted as both inspiration and invaluable instruction. It offered inspiration by demonstrating that survival was indeed possible, even under the most dire and seemingly hopeless circumstances, and it provided crucial instruction, underscoring that the P-47 was far tougher and more resilient than its initial appearance might suggest, and therefore unequivocally deserved, the pilot, is implicit trust. Robert Johnson had, through his incredible ordeal, definitively proven that Alexander Kartveli, seemingly obsessive commitment to over-engineering was not an exercise in waste, but rather a profound manifestation of wisdom, illustrating that every additional pound of structural reinforcement and every redundant system had a vital purpose, a purpose ultimately measured in precious lives saved and critical missions successfully completed. The P-47 Thunderbolt proceeded to undertake more combat missions than any other American fighter aircraft in the European theater, accumulating an unparalleled combat record that irrefutably validated every controversial design decision Republic aviation had made. It destroyed a greater number of ground targets, flew more demanding escort missions, and successfully brought more pilots home safely than its lighter, more aesthetically elegant counterparts that often appeared superior only on paper. The pilot's extraordinary survival on May 26, 1943, stood as the ultimate proof of concept, fundamentally altering how everyone, Americans, British, and Germans alike, understood the true limits of an aircraft's endurance. The Luftwaffe, chastened by experience, never again casually dismissed Thunderbolts as easy kills, for Johnson had demonstrated to them, in the most definitive and unforgettable manner possible, that destroying a P-47 required far more than merely hitting it. It demanded the complete annihilation of a machine that, against all odds, resolutely refused to be destroyed.